In this video, we're going to take a look at how to use the definition of the derivative to find the derivative of a polynomial function. You might know there are formulas that allow us to find the derivative more quickly, but fundamentally all of those formulas are based on the limit definition of the derivative, and so it's nice to be able to use the limit definition from time to time. So part of the goal is to demonstrate that we're using the limit definition. So I'm going to start by carefully filling in the details. F of x plus h in this case is negative x plus h squared plus 9 times x plus h. And then I want to subtract from that the original function, negative x squared plus 9x. And what we'll see with a polynomial function like this, we can expand the numerator in a way that lets us cancel out the h in the denominator. Because right now that h in the denominator is causing a problem. I can't actually take the limit because I can't plug 0 in for h. I can't evaluate the limit algebraically at this point. But after we simplify the expression, we'll be able to do that. The goal of the problem is to demonstrate that process. So now I haven't taken the limit yet, so I'm going to continue to have the limit as h goes to 0 as part of my problem. And I can work on expanding the numerator. X plus h squared is negative x squared plus 2xh plus h squared. I can distribute the 9 to the two terms in parentheses, 9x plus 9h. And then finally we can distribute this minus sign to the two terms here as well. And we end up with a positive x squared minus 9x. All of that is still over h. You'll notice that the positive 9x cancels with the negative 9x, and we can also distribute this minus sign across to all of those terms. And when we do, the negative x squared here is going to cancel with the positive x squared there. So let me actually go ahead and do that. And in the next line, write the limit as h goes to 0, because we haven't taken the limit yet. And I get negative 2xh minus h squared plus 9h divided by h. And what's kind of cool about this, what you'll notice is all of the terms in the numerator here have an h in them. So I could factor out an h. Again, I haven't taken the limit yet, so I'm going to write the limit as h goes to 0. I can factor out an h, and it leaves behind negative 2x minus h plus 9. Because the negative h squared, I take away one of the h's, and one is left behind. All of that is over h. And now, because h is clearly a factor of the numerator and a factor of the denominator, the only thing in the denominator, I can cancel out those h's. And this puts us in a position to be able to actually then evaluate the limit. So let me write this out a little bit more clearly first. I can write this as the limit as h goes to 0 of negative 2x minus h plus 9. But now I can send h to 0 as the limit is telling us to do, and what's left is negative 2x plus 9. So notice in this last step I dropped the limit notation because I've evaluated the limit. So that expression is now an expression for the derivative function. And there we have it. The derivative of negative x squared plus 9x is negative 2x plus 9, using the limit definition of the derivative.